Chapter 8, Section 6, Factoring ax squared plus bx plus c. This is going to be very similar to Chapter 8, Section 5. When we were talking about Section 5, we had the constant 1 in front of my x squared, so it was just x squared plus bx plus c. Today, what's going to be different is we're going to have a number besides 1 in front of my x squared. To factor ax squared plus bx plus c, it's going to be similar to factoring x squared plus bx plus c. But to factor ax squared plus bx plus c, we're going to look for factors of the product AC that have a sum of b. So this is similar to what we were talking about yesterday, because just like yesterday, we need the factors to have a sum of b. But the difference is now we're going to find factors of a times c instead of just c. This first example says, what is the factored form of 3x squared plus 7x plus 2? Notice in this case my a is 3 and my b is 2. We need to find the factors of ac, which is 3 times 2, which is 6. So just like yesterday, we're going to make our table, but now we're going to write the factors of a times c, which is 6 in this case. Factors of 6 are positive 1 and positive 6. Notice my b is positive, so I need to write the positive factors. 1 plus 6 is 7, and then 2 and 3 are also factors of 6, and their sum is 5. We need to use 1 and 6 because I need the sum to be equal to b, which is 7. This is where a big difference comes in on factoring from yesterday to today. What we need to do now is we need to take the factors 1 and 6, and we're going to leave my 3x squared and my positive 2 alone, but we're going to rewrite 7x as x plus 6x. So all I've done is I've left my 3x squared alone, and now instead of 7x, I have 1x plus 6x. And then I've left my 2 alone. What I'm going to be able to do now is I'm going to be able to group these terms into pairs and find the GCF of the pairs. So we're going to find the GCF of the two sets of terms. My first set of terms is 3x squared plus x. The GCF, or greatest common factor, of 3x squared plus x would be an x. And then if you look at the second set of terms, we have 6x plus 2. The GCF of 6x plus 2 would be 2. When I factor out the x from my first set of terms and my 2 from my second set of terms, I'm left with x times 3x plus 1. And then I'm also left with 2 times 3x plus 1. This one works out very nicely because notice inside of my parentheses in both of these binomials, I have 3x plus 1. Now I'm going to kind of do the opposite of the distributive property. I need to take my terms in front of the 3x plus 1, my x and my 2, and I'm going to be able to take those two terms and I'm going to combine them to create a new binomial, x plus 2. And then I'm going to leave the binomial 3x plus 1 alone. So I'm going to have x plus 2 times 3x plus 1. Just like in all of these examples so far, I need to go ahead and check my answer. Go ahead and multiply your first terms. X times 3x is 3x squared. Your outside terms, x times 1 is 1x. Your inside terms, 2 times 3x is 6x. And your last terms in your binomials, 2 times 1 is 2. Now go ahead and combine your like terms. X plus 6x is 7x. And I have checked this answer. It does multiply together. The two binomials do multiply together to give me my original trinomial. This next example says, what is the factored form of 2x squared minus x minus 3? Just like in the last example, now I need to multiply my a and my c first. In this case, you need to be careful because if you look at that trinomial, I have a negative c, I have a positive 2a, would be a A -1 would be my B, and a -3 would be my C. The product of A and C, 2 and -3, is -6. The only way that I can multiply two numbers to give me a negative product is if I have a positive and a negative number. In this case, I need the sum of the factors of -6 to equal -1. So I've listed my pairs of factors of -6. We have -1 and 6, which would have a sum of a positive 5. We have 1 and -6, which would have a sum of -5. -2 and 1 and 3 would have a sum of positive 1, and 2 and -3 would have a sum of -1. I need the sum to be -1, so the two factors I'm going to use are 2 and -3. Just like in the last example, now I need to rewrite my trinomial. I'm going to rewrite it as 2x squared plus, I'm going to use the factor 2x, then I'm going to use the factor minus 3x, and then minus 3. Just like in the last example, again, I'm going to go ahead and group my terms in pairs of 2, and I'm going to find the GCF of the two sets of terms. 2x squared plus 2x would have a GCF of 2x. Negative 3x minus 3 would have a GCF of -3. When I factor out my 2x and my -3, I have 2x times x plus 1 minus 3 times x plus 1. Notice again, these two binomials that are created are the same. I have x plus 1. I'm going to go ahead and combine the terms outside of my binomials, outside of the parentheses. 2x minus 3 would combine to give me a binomial, 2x minus 3, and then x plus 1 is going to be left alone and just brought down. Go ahead and check your work. 2x times x is 2x squared. 2x times 1 is 2x. -3 times positive x is minus 3x. And then -3 times positive 1 is a -3. Combine your like terms, 2x minus 3x is a -1x. This trinomial that I have as the answer to these two binomials multiplied together is the original trinomial that they gave me to factor, so I know that I have the correct answer. This next example says the area of a rectangle is 4x squared minus 7x minus 15. The width of the rectangle is x minus 3. What is the length of the rectangle? To find the area of a rectangle, remember you multiply length times width. I know that one of my binomials is x minus 3 because they tell me the width is x minus 3. If you look at the original trinomial that they gave us, when I multiply my first terms, if you think about foiling, I'm not sure what my first term is for the length of the rectangle, but I know when I multiply it by x, they need to have a product of 4x squared. Well, what times 4x times x equals 4x squared? When you ask yourself that question, well, 4x times x is 4x squared. To get your second term in your first binomial, think about what you would need to multiply by -3 to get c, which is -15. Well, what times -3 is -15? The answer would be a positive 5. If you were to check this answer using the FOIL method, you would find that they would multiply together to give you the trinomial 4x squared minus 7x minus 15. Sometimes you're going to be able to find the GCF of a trinomial and factor it out first. If the whole trinomial, the three terms in your trinomial have a GCF, you're going to factor it out, and then you're going to factor the remaining polynomial until it can no longer be factored. An example of this would be, what is the factored form of 30x squared plus 14x minus 8? Notice 30, 14, and 8 all have a GCF because 2 can go into all of those numbers. What I'm going to do is I'm going to go ahead and factor out a 2. When I factor out a 2, I would be left with 15x squared plus 7x minus 4. What I need to do now is I need to factor the trinomial 15x squared plus 7x minus 4. The 2 is going to stay there. It's not going to go away. I just need to remember to keep bringing it down because it's already been factored out. The first thing I need to do is find AC. In this case, A is 15, C is negative 4. I need to find factors of 4 times negative 15, which is negative 60. I need to find factors of negative 60 that have a sum of B, which in this case is 7. 12 and negative 5 have a product of negative 60, and they have a sum of 7. So I'm going to use 12 and negative 5 as my factors. I'm going to have 2 times 15x squared plus 12x minus 5x minus 4. All I've done there is I've rewritten 7x as 12x minus 5x. Go ahead and group your terms just like we've done before. 15x squared and 12x have a GCF of 3x. And then negative 5x minus 4 have a GCF of negative 1. Notice I have the binomial 5x plus 4 repeated twice. I need to combine 3x and negative 1 and bring down my 5x plus 4. Do not forget to continue to bring down the 2 that you factored, the very first thing that you factored out during all of these steps. So we're going to have 2 times 3x minus 1 times 5x plus 4. Today's assignment is page 541. It's numbers 1 through 7, 8 through 26 even, and 35.